You are live.
I'm live. Wow.
Yeah, get on camera, dude.
Oh man. Oh, it's so far. 8 inches.
Yeah, almost as far as you trying to do a push-up.
Yeah, that didn't work out too well, did it?
I said it wouldn't work out for me either. Can we get an audio and video check, please?
I would have thought I could get at least 10. Hell, I couldn't even do one. This arm, that muscle there is something a little wrong with it. Don't know why.
Well, it's your non-dominant arm. It may not be.
I don't know. Hey, John. We'll wait for a couple other people to shows up. We had kind of a busy week. Things kind of happened a little bit. Good. 5x5. Okay. Apparently it's doing fine, little one.
Okay.
So
I'm probably gonna take off.
Okay. So anyhow, the weekend we didn't have stuff to do in the field, so we were kind of kicking back a little bit. Then yesterday, or the day before, I realized, I've still got those samples from Central America that they left here. It had a couple of them, so I thought, well, I can make my own sulfide concentrates. And I was also waiting to do some testing of Propsector Tripp's equipment. He sent me a smooth water concentrator and square pans and stuff. And so I was wanting to test those. I thought, well, perfect. I'll just use that. So that's the video from yesterday. And actually, I think it was Saturday. Yesterday I was roasting concentrate. So anyhow, I think it was Saturday I made the concentrates. Yeah, it was Saturday, because I was up to like 10:30 or something. Standing. Neck got sore. But anyhow, they were all dry by Sunday morning. So Sunday afternoon, I started roasting them. And that video's not up yet. Took a lot of video there, and was roasting the concentrates. And I came up with a system. See how this shows. Okay, I take one of my little black cardstock cards. Write down what the sample is. In this case, it's across the road sulfides. This is that silver stuff from that one sample that was so much of it. And then I put how many, the number of grams of the sample I had. This is what I panned this morning. We sent off some for assay, and then I just panned the rest down and got, what was that? 62.41 grams. And then I take a little drop of white glue, stick it on the card. Hey, David. And then put some of the sample on there. And so now I have a permanent record of this particular sample. Not only how much it weighed, but what it actually looks like. And I don't have a good way of taking photo micrographs right now, but I don't even need that. In some ways, I would presume this is a little better than a photo micrograph, because you can always go back to it. And then once I roast this, I'll be roasting this tomorrow. Then you wind up and do a similar card with the roasted cons and how much that weighed also. I seem to be getting, at this point, about a 25% reduction in mass, which, if I'm doing the chemistry right and the molar math, I'm actually losing a little more than I should be. I'm not sure what else is volatilizing besides just oxidizing sulfides. But anyhow, so that seems to be a nice system. And I've got a video in the works. I still haven't got done, but the gold leaf showed up today. So I will be starting my solution testing presumably tomorrow. I will presumably do the Eco Gold X first, and then the thiosulfate, and I can compare that. And then I will be doing the glycine testing and seeing how that works. Each one is going to be multiple tests to see if varying parameters makes a significant difference to the speed of dissolution. And some of the things are oxidation potential, temperature, solution concentrations, things like this. See what kind of optimizes it with the gold leaf. Now, that doesn't guarantee anything when you're dealing with actual concentrates or whatever, because you've got much more complicated chemistry there. But that's what I want to do. I can also, when I concentrate free gold from the concentrates, I can go ahead and test and see how long, when I'm just putting free gold into a beaker, stirring it with a solution, how long does it take to dissolve? See how fast that occurs. It is my hope that with roasted sulfide, you could achieve essentially 100% dissolution in well less than 24 hours. So you can have like a 24-hour cycle where you spend, say, 20 hours in a bottle roll, and then you put it in a filtration electroplating situation. And hello, Jean-Francois. You're early tonight. Glad to see you. So anyhow, hey, John. Breaking screen on the left. Well, that's not good. So anyhow, if we can get essentially 100% dissolution in less than 24 hours, hey, honey bunny, then we could have a system where the bottle roll is running for one shift, so to speak. I mean, during one 24-hour period, it's bottle rolling. Then you move it to the extraction from solution, say, in the next one. Hey, Rock, how's it going? I haven't seen you in a couple of weeks. You must have been busy. I hope it's been working well. And so, if we can dissolve the gold out of the sulfides within a 24-hour cycle time, and then get them out of solution in another 24 hours, it'll make for a very simple setup in an actual production thing where your crew will be processing ore for a day. Then you take those concentrates, you then the next day dissolve the gold from the concentrates, and then the next day recover the gold from the solution. Oh, so anyhow, we'll see how all that theory works out. When I get the bulk sulfide samples, the first test I have to do is volatilization test. It is possible certain chemicals of gold, etc., they can actually vaporize when you're roasting the concentrate. So you have to be very aware of the possibility and check for it. Okay? So we're going to test that. We need to know what the grade of the concentrates is, whether or not roasting vaporizes a significant amount of the gold, and then what's the best way to dissolve it, and what's the best way to get it out of solution. If there was significant volatilization, we might do like a two-stage leaching setup where we leach it first to get the free gold and the gold that has mineral exposure, and then dry it out and roast it, and then dissolve it again. Leach it again. It may be that all the gold that's going to tend to volatilize, you're going to get in the first leach pass, or even if it doesn't, if say you got, I don't know, say 20% losses, then if you recover 70% of the gold before you roast it, well, you just save 70% of those losses. You would normally roast pre-leach, but if you're going to vaporize gold, you might want to check it out. Man, been busy with the event. Well, I hope everything worked out well, Rock. So those are some of the options we're looking at, depending on how the testing goes. If the dissolution is effective enough and fast enough, we may pretty much eliminate a lot of the processing in terms of, we may just suck off the clean gold off the table that you see, because hell, it's right there, might as well get it, and then not even worry about cleaning up the sulfides anymore. Just go ahead and leach them. We'll have to see. And so these are some of the things we have to ascertain with testing and crunching numbers. Currently they're tabling it, and they're retabling it, and then they're sucking off the gold line plus a little bit of the sulfides there. And it could be, Jean-Francois. We shall have to see. But then they hand pan the gold, which is what I thought that Propsector Tripp square pan would be exceptionally good for. And then they take that high gold concentrate and roast it and then smelt it. Depending on how stuff works, we may completely avoid all of that. We shall see. We're still going to want to do a gravity concentration, assuming that the vast majority of the gold, 90% plus, for example, is in recoverable sulfides and free milling gold. Okay? It's just one of those things. You have to talk to the rock and let it tell you what it'll cooperate with. But it's within the bounds of possibility at this point that the grinding and gravity separation will be sufficiently efficient that the tailings are not worth setting up a heap leach for or anything.
Hi, Michael.
So that's going to be, again, one of the questions we answer. Right now, they're focusing on gravity gold to get income, right? That's the thing. By retabling the, well, let me make sure everyone knows what I'm talking about. When you first take the ore and you crush it up and you run it over a gravity process or any other process that like that, like flotation or whatever, that first pass is what they call a roughing pass. Its job is to get rid of the vast majority of the worthless rock without losing much in the way of valuable minerals.
By the way, David, talking to rocks may be a new thing to all y'all, but the goddess has been talking to rocks for years.
So anyhow, we go ahead and and take a look at what's going in the tailings. Right now, hand panning the tailings shows no free gold, no detectable free gold, and a bit of sulfide. There's reasons the sulfides can wind up in the tailings. One of the big possibilities is just they're floating off. When you dump it in the distribution trough at the top of the table, the gold, not the gold, the sulfides are very hydrophobic. They tend to float. And so they might be floating and just heading straight down to the tailings chute, a trough. One way you can deal with that is some kind of a chemical that improves the wetting agent, some kind of surfactant or whatever. But there's a couple of problems with that. Number one, in this case, they're not able to recirculate the water too well because it gets real dirty real fast. So then you probably have to add a flocculant also. So right now they're basically just using fresh water. Well, that would take a lot of surfactant to do that. And so that would be very, it can consume a lot of chemicals and potentially cause some kind of pollution issue.
See that?
Well,
Rock Butcher talks to rocks and lays hands upon them as well.
Wow. And but another method that might work well why would we want to use recirculated sulfuric acid, Jean-Francois? But anyhow, one way you can potentially deal with this, let's say here's your distribution trough, your tabletop. You take and lay a sheet of thin rubber or plastic or something on here. As the material comes out of the openings of the distribution trough, it forces anything that's on top of the water under the water. And that might be enough to dramatically reduce the issue to the point where it's no longer significant. Don't know. I told them to try it. Haven't got word yet on whether they did and what happened. And so the wiper, I think is what they usually call them, might make the difference to the point where there's hardly any sulfides getting to the tailings. Problem solved. We'll see. But it's looking more likely that the losses in the tailings are basically sulfides, as opposed to gold still stuck to the tailings. So that's another potential issue that we're looking at here. The sulfides, after the rougher pass, what they used to be doing, here's your rougher table. You have your number 1, 2, 3 tailings. Tails are in a trough right here. Cons go into a trough here that's got dividers.
Oh, sorry, Jean-Francois. I didn't even realize I was whistling out loud. Okay.
Anyhow, what they were doing, taking the 2s and 3s, combining with the tails and throwing it away. That is no longer being done. They have found that if they take these 2s and 3s and retable them again, what's known as a cleaning pass, they get a significant amount of gold, especially in the number 2 stuff. Number 3s have mainly sulfides, with very little to no detectable free gold. 2s definitely have gold. And so by doing that, the recovery of gold and sulfides has gone up dramatically. And therefore, theoretically, their profitability should be going up. We shall see. Again, it takes time to get all this stuff tested. And but again, we're making more and more steps. Each one, almost each one, improving. They tried a different flux recipe this weekend that didn't work too well.
I wasted.
But anyhow.
Well, yeah, it was a stupid idea. Hi, Sarah.
Hey, Sarah. So these are some of the things we're doing to try and improve the recoveries. And they're now working on improving the production from the mining end.
I had not heard that one, Rock Butcher.
Neither have I. So anyhow.
My grandmother used to say all kinds of things would get your face stuck that way and nobody will marry you.
Ah.
Never knew what it was going to be, but...
So, anyhow, now they're also working on increasing the production. And one of the things that I re-suggested that they still haven't addressed so far, there's a bunch of dumps out there. If you remember the picture from beforehand, that's a pretty big hole in the ground. Most of that hole was not processed. Most of that hole was waste rock. The color of the rock looks reasonably consistent. If you want, maybe you could. First of all, I'm not showing there.
No, I had it on the side of the podcast.
Okay. Can you do the one with the line? Okay.
Take a minute here, folks. Here, I'll put that back up there. I tried.
Okay. My grandma told me that when I was a kid, huh?
Yeah. Your face will get stuck that way and you'll never get a husband.
I don't want a husband.
No, we all know how that one goes. My face never got stuck that way. Looking for the picture he wants right now.
I think, look at the top, there should be A.
Here, I found it. Hold on.
Yeah, there you go. That'll work.
Okay, guys, I'm going to put this on the screen here.
Okay. So anyhow, I can handle the thing around. Right here is the portal. Now, I do not see a dramatic difference in color across this face here until you get to here. Okay? And maybe over to there. So, it's my belief that between here and there, undo that.
Yeah, that's fine, Trent. Let me...
Well, that's fine. You said you need to go to the bathroom. Okay? So anyhow, it's my belief that all of this is probably low-grade material with some richer concentrations in it. As such, when they made this gigundous hole here, if they were smart, which they very likely were not, they would have stockpiled this material someplace different than when they dug over here or over here. But I suggested to the guys down there that they take and check those dumps to see how good the grade is there, because it may be that they can get marginally profitable material very easily. And that way, when their tunneling crews don't keep the mill fed, they can just switch to dumps and still keep operating at a profit. So that's something that needs to be tested.
This is what Honey Bunny saying about that.
What?
That it looks like a mesh tape layout of lighter, vaguely like a trap or large. It does. I mean, if you take a look at that area, yeah,
Yeah, you got a lot of cross faulting there, cross veining and everything, but from here to there, it looks fairly consistent. So that may be ore. Now, when they went and dug the hole and threw stuff in the dumps, it's entirely possible that they mixed it up and kind of ruined the whole plan. When you are excavating, don't assume anything you can't make money on is waste.
Mr. Virtue says got garnet. I believe he's meaning to say garnet rather than granite.
Big black
misspelled.
square.
Why do we see a big black square? That big black square that keeps coming and going, Jean-Francois, is the stupid chat. Okay, I don't know how to do it.
Anyhow,
Rock Butcher says unless they were hand to mouth like most of the old works in Montana, most people don't drive access on ore, low or high grade. Sterilize a pile of rock until like fine. Yeah. Sarah says, "Wow, it's so big." Actually,
yeah, that's not very big.
That's a little itty bitty. Yeah, the big black window.
I don't know. Is he talking about this or that?
Are you talking about the thing that's moving right now, Jean-Francois? If you are, that is the chat box from YouTube.
If it's this or that, those are tunnel openings.
If it's this thing over here,
that's an excavator.
If it's these things right here,
yeah,
those are mines.
Those are tunnel openings.
Tunnel.
Yeah.
Yeah, the big black square is the freaking chat window from YouTube that I cannot do.
Jean-Francois. The phrase yes is not definitive. She had two different options and you said yes.
Well, of course he said yes. He's doing a Jean-Francois thing. Don't ignore it. Just ignore it. Yeah, that's a stupid chat box. Ignore it, people.
Yeah.
There's nothing I can do about it. All I can do is move the thing to show you stuff.
Yeah.
And then we can't read your words or type them.
Yeah, so go ahead and move where I can see it.
He can't see it if I move.
Yeah, it's not hiding anything important there. So, if you were digging this hole...
Yeah, well, here. I will keep the chat box over here.
Okay, then you'll have to read it to me.
Yeah, Rock said stop moving the chat window over the... Okay?
Well...
That's what's going on now. Don't pay
anyhow, so if you were digging this hole, it would be advantageous to take the rock that you're throwing away and sort it into low grade.
Well, that was a bad idea.
And absolute waste. Now Eva's got things kind of
now the chat window's all fucked up. Thanks a lot.
Well,
no, I mean I can't get it full size again.
Get it over there and don't worry about it. Okay? But anyhow, so as you're moving material, try and get an idea of what you are looking at. I mean, move it over where we can get and leave it there.
Don't move it. I need to get it fixed so I can actually see it myself. Will you leave me alone? Okay, that's the last time I moved the window out of the way for all y'all.
That's right. Put it back where I can see it and then don't move it.
I can't get it to full size again, dude. Will you please leave me alone?
Okay. Anyhow, so when you're moving material, if it's got nowhere close to profitability, stack it in one place. If it's, well, if the price of gold were to double or triple, it could be profitable, stack it in another place. If it's, we could make a profit on this, but we don't really want to use it because we got better stuff, stack it in a third place. And this is how you can not waste material. If you take everything that's not high grade and throw it in one spot, it's probably useless now. So it's important when you're mining to keep an eye on what you are doing in terms of what the particular rock you're moving is, and sort it by type. Sometimes it's a matter of chemistry. You'll have oxides and sulfides. You'll have carbonaceous ore and non-carbonaceous ore.
Now, muscle, I can barely manage what I've got right now, okay? I would love to be able to spend the time to learn how to do tech, but then this yo-yo would expect me to do even more tech, and I don't want to waste my friggin' time with it. And yes, they should have a constant fee inclusive taker table. Money.
Yeah. So they've got a reasonable distributor box, four tables running in parallel.
For bed. Rock's gone to bed.
Okay, you take care.
He's got to get up early.
Yep. So, anyhow, the idea of digging a hole this big and throwing it all in one spot is inefficient. Hopefully, they've segregated it to some extent, and therefore the new guys can utilize it and have like a low-grade stockpile just sitting there. But they have to test these things to find out what they got. It just doesn't magically appear. Okay, you just got to do what you got to figure these things out. So hopefully they can find at least a section of the waste dumps that are profitable low-grade ore and can supplement the tunnel production with that so they can increase total mill production. It appears that they can basically make money on anything they haul out of that tunnel, just sometimes a lot more money than others. So that's one of the things they're working on right now is to increase the material flow to the mill. They've been spending so much time on the milling itself that has kind of gone by the wayside. So that's where we're going there. Is the ore vein the red material? Yeah. The actual ore vein is the slightly red, the slightly darker material. See where the tunnel entrance is? That's higher grade, but that whole material in the corner there, that's essentially the mineralized zone. I don't think they were carried away. They were thrown over the side of a hill somewhere. Well, a lot of the question on that heap leaching, Honey Bunny, there's some challenges. First of all, a lot of this ore is not heavily oxidized, so you have a lot of gold trapped in pyrites. That doesn't heap leach very well. Heap leaching itself generally is only 60 to 70% efficient at getting gold out of the rock due to the fact that you don't heap leach fine sand. Okay, you crush it down to about 1 inch. Okay, and therefore the losses of 30%, if the ore is rich enough, let's say you had 1 ounce to the ton ore, okay, and 30% of that would be 30% of, what is it now, $3,500? 9.3. Okay, $1,000 a ton you're throwing away. Now, that's a lot of money. a more expensive processing option will give you a higher recovery. For example, if you had heap leaching, I can take it. Like heap might be 60 to 70%. Vat leach, call it 80%. Tank leach, agitated tank, 90+%. Okay, so 20% of 1 ounce to the ton would be $700. $700 difference. This cost might be $100 a ton. This would probably be more like $30 a ton. And this is more like $15 a ton. Okay. Now, heap leaching can be the best option for low grade ores, but is rarely the best option for mid to high grade ores, simply because the cost of a more efficient process more than offsets the increase in gold recovery. Okay, so you would not generally be heap leaching ore of this grade. Okay, now the stuff in the various dumps might be very readily heap leachable. Now you get into the next problem, and that is they have something called a rainy season. And when you have a heap leach, you essentially have a giant parking lot out there. Now, when it rains a lot, the rain lands in the parking lot, it's got to go somewhere. In a heap leach, that rain is diluting your solution, and you don't want it to be diluted too much or carried off or anything like that. So when you have a heap leach setup in a rainy area, you may want to take and make a reloadable pad where you stack your stuff and leach it during the dry season, then unstack it and divert the water in the rainy season and go back. So if you have an area with substantial rainfall, heap leaching can have some serious problems. Okay, so that's why it's not just an obvious option in this particular case. Okay, I'm also not that familiar with the terrain. As you saw from the photograph of the mine, there seems to be pretty hilly right here. Now, there may be a fairly flat spot somewhere close by that's accessible, but I have no knowledge of that. Right now, we're not dealing with it. That's 3 or 4 major phases down the road if it makes sense. Okay, so these are the kind of issues that you have to take into account when coming up with a plan to exploit such a situation.
Yeah, their monsoon season's 11 months and 29 days a year.
No, not that much, but they also get hurricanes.
Yeah, they get hurricanes. Well, it's always raining. Every time we talk to them, it's raining.
No, not that much. Yeah, exactly, John Francois. Well, if you're using thiourea, that would be helpful.
Wait Slave has a question about gold volatile. Gold chloride, dude. Gold chloride, like silver chloride, is very volatile.
Yeah, I say you can have.
That's one form.
You can have compounds of gold and such. I'm not an expert on it, but I know the gold chloride in the presence of iron pyrite can vaporize like a son of a gun.
At ordinary household oven temperatures.
Yeah.
Been there, done that.
Doesn't have to be that one in the Bureau of Mines, what was that, 300 degrees C?
Yeah.
That's more than a normal oven, but not too much more.
Yeah.
Definitely well below roasting temperatures for sulfides.
Exactly. And I will never let you live down the fact that I told you from the beginning I thought the shit was volatilizing.
Dan from over in Washington State says the ores over there tend to have that problem. I don't know. I have no firsthand knowledge. He seems reasonably knowledgeable, but I don't know that much. But I know that he says, yeah, ores over there can lose 30 to 50% of the gold during roasting. Now, can you counteract that, as Jean-Francois suggested, by using a scrubber? And that's a possibility. Again, there's a lot of information out there that isn't in my head. So I got to do stuff a lot by just the try it and see method. You know, I don't know where the gun's pointing, so let's point at the target, pull the trigger, and see where the bullet hits. Yeah, pretty much. Empirical. There you go. That sounds much classier than just guessing.
It's called being a naturalist, dude. Darwin.
Yeah.
Naturalists practice empirical science.
Yeah.
Science through observation.
So, anyhow, that's the situation. Another thing you could theoretically do, honey bunny, if you have a relatively non-toxic leaching solution, is you can make a covered leach pad. Okay? And depending on the volumes you're trying to do, you might be able to use that, 365 days a year, except for when the hurricanes are rolling through. But again, that's down the road a bit. Right now, we're worried about stuff that's really immediate. And right now, we got them recovering the gravity gold and apparently some of the gold in the sulfides, because the sulfides that are associated with the gravity gold, sometimes they're recovering pretty well out of the roasted sulfides from that. Yes, that's the thing. You've got capital expenditures, you have permitting expenditures, you've got permitting constraints, you've got physical constraints, economic constraints. There's all side of things. Get investors, right, David? And you got to pay the investors, and then the investors have a say in things. So now you got to herd cats. And so you try and avoid adding more investors whenever you can, unless you are simply mining the investors. If you're mining investors, that's just fine. I don't work that way, but there are some people who made loads and loads of money mining investors exclusively. They set up a project, they promote it, they get people to invest in it, they pay themselves a nice hefty 6 or 7 figure salary, and then when it goes broke, they just do it again.
Oh, heck, there are folks that have made money selling bogus.
Well, I'm talking about millions of dollars on a single project. This is not uncommon at all. The biggest scam was $2 billion.
Yeah, I'm aware of that.
So, I say, it's possible, but these are some of the constraints. The gentlemen we're working for, they are essentially the investors. They came into, and hey, Chris, how's it going?
Hi, Chris.
They came in to basically provide investment capital to put in new tech and improve the throughput, etc. So they certainly don't want to complicate the issue any more than they've got. So I say that's my job, is to try and make it work, figure out how they can make it profitable, nicely profitable, without having to invest any more of their own money or outside money. Just improve throughputs and efficiencies, initially things that can be done very cheaply, and then go from there. We have no idea how much gold is in these sulfides. It looks like it's pretty darn good. They're pretty darn concentrated. And typical roasting temperature, what would you say, Chris, about 1,000 to 1,200 degrees to roast sulfides? Almost, glowing, a dull red sort of thing, or just below that seems to work okay. The values in the pyrite, could be as much as $1 a gram, or
David Villa says
1,600 what?
I
1,600 degrees.
I
That's
don't
pretty
usually
high
roast
for
that
roasting.
hot.
Yeah, that's pretty. Let's see.
I was roasting at like 1,200. The few little things I roasted.
Do you recall what I said? $1 a gram or $10 a gram? $1 a gram, right? I think.
It was around $1 a gram is what you think, but we don't.
Take care, Jean-Francois. As I recall, one of the estimates was somewhere in the neighborhoods about $1 of entrained gold per gram of sulfides.
Chris says 12 to 17, depending on ore and flux.
No, I'm not talking smelting direct. I'm talking just roasting first.
Yeah, I was roasting around 12, 13.
Say, just the roasting part. And so, because the idea is to roast it and then leach it, is the plan for the sulfides themselves. Trying to remember. Gosh. Oh, I remember what it was. Okay. 4 grams per ounce. Yeah, it's about $1 per gram of sulfides is kind of the first estimate from some of the assays, but that's not from actually analyzing the sulfides that they're getting right now from the process now.
No, roasting before a smelt is what they're doing at the moment.
Yeah, we're planning on just smelting before leaching most of the bulk of the sulfides. And well, that's not good, honey bunny.
Well, Mr. Virtue, when you're roasting, you're not really melting rocks. You're breaking up sulfide, which is...
Well, smelting you are kind of... Well, actually, you're more dissolving the rocks.
No, roasting.
In a flux.
You're not, though. You don't need it that hot.
Yeah. I say just about where it starts to glow a little bit is about the temperature that will heat it up enough that combined with air, you'll convert the sulfides to oxides. It's also plenty hot enough to volatilize things like mercury and arsenic and stuff like that. 900 to 1300, yeah. If there's certain heavy metals in the sulfides, it can be quite hazardous. So the multi-element analysis we've done to this point indicates we don't have high concentrations of volatile heavy metals like mercury, arsenic, antimony, stuff like that. So that makes it plausible to just roast. And say when I roasted it last night, I came up with a lot of free gold just appeared out of nowhere. Okay, because the roasting just broke it away from the oxides. when I put it in a blender and blended it wet to uh, just try and bust up the oxides better. It also busted up the gold to where I had less gravity recoverable gold from the roasted sulfides before grinding than after grinding. So, I say it's interesting, but it definitely did give me a bunch more pannable gold. But I could still see gold. This little Carson microscope we got, it's actually pretty darn good. You have pretty good resolution. So I'm very pleased with it. But it's not good for taking pictures, which is really, really annoying. Um, but anyhow, so that's kind of where we're at right now. Within a week, I should have some bulk samples of the sulfides they're actually making at the actual mill at this time with the processes that are currently being used, which is what you really need.
Springs eternal.
Now, with Prospector Tripp, his little inventions were pretty interesting today.
He'll be right back, folks.
I was thinking that his square pan might be exceptionally good for our trying to get the free gold out of the sulfides. So, blender, yeah, well, once you roast the sulfides, they tend to stick together and stuff. So I just put them actually in a blender with some water and just beat the heck out of it for, I don't know, maybe a minute just to grind it up. But anyhow, this pan I was thinking would probably work pretty well. What?
Yeah.
In order to concentrate the gravity gold out of the sulfides. I mean, you're dealing with, basically black sand. And by liquefying it and tipping it this way, running it over the riffles, it seemed to do a pretty good job of getting the sulfides away from the blondes. And then by using the gentle slope, I was able to do a pretty good job of cleaning off the blondes from the sulfides and the oxides. So if you were doing it with the high gold concentrates and, just run stuff off, and you're going to have like lines of gold in these things right there. Well, on that note, Chris, this is Matt's smooth water sluice. Okay, it has a little pump that goes in here, and then it runs water down here. By tipping it, it advances the material very gently over this slightly textured surface there. And it seemed to, if you didn't run it too fast, it seemed to do a fairly good job of trapping the gold in the riffles here, the drop riffles. But as a matter of fact, he said he made it last night. He made one, it's a little bit wider, a little bit shorter here. It's all drop riffles. And the idea is to put a vibrator on it, and so that basically as you're feeding the sulfide cons that have a large quantity of free gold in them, the gold will get trapped in these riffles, and then you can suck them out. That's the plan. And He'll get that to me in a bit. He's looking for a bigger vibrator because this is about as big as he thinks the vibrator he's currently using can handle, and we made it wider and taller so that these sumps are bigger. And this sump here now going to go across to here with a weir in there to maintain a steady level on the sluice side, and the fluctuation will occur on the pump side. Okay, so he's making me a special model of this, and we're going to see how that works too. Today I was using the square pan to pan the across the road material to get the concentrates out of it. Yeah, it could be, Chris. Would not be surprised. But this worked better than one of my regular finishing pans.
Poker face, yes. I can't quite decipher the question.
What are we in this for? Money and fun. Okay?
Yeah.
If you're making good money, it gets kind of fun. But anyhow, this seemed to work better, substantially better than my standard pans for getting a large amount of sulfide heavies out of a large amount of material. And so, but my pans that I normally use have very small riffles on them too. So it may be the riffle design that, although it was easier to clean with this than the regular pan too. Yeah, there's a possibility there, Kodak. Rather than the horizontal drop riffles, you could printing one with prismatic facet drops. I don't know, Chris. I don't know. I think the drop riffles will do okay for what my purpose is. As for what the normal person's purpose is, I really don't know. My job, or the task that I'm looking for, is to get gold out of sulfides, and everything's 100 mesh minus or pretty close to it, because it's all gone through a 100 mesh screen. Now that is not the normal situation. Normally you're going to have a lot bigger particle. Wow, thunder. A lot bigger particles in there and stuff like that.
Hi.
Hi, Shane.
Wow, sounds like you've had a great day today, Shane. Busy.
Yep. So I was pleased with how well this worked for my application. Not sure in which ones it's better than a pan or in which ones it's not. You know?
I agree, actually, Chris. Prismatic facet drop sounds interesting. They look like little pyramids pressed into the plastic, Jeff. He asked what a prismatic facet.
I don't know.
Like if you took an upside down pyramid and you know.
I really don't know. Again, I'm not so much a amazing theoretist.
P-Man says the choke plate's in the mail. Hi, P-Man.
Thank you. I appreciate that. But we'll see what happens once I get the actual samples. I can get actual assays on them, do the roasting, see how that affects things. I have no idea, Chris. Isn't that essentially what a Wiffley table is to some extent. Um, One of the problems or complications that I see is that some of the gold particles are nice little balls and some of them are not. And the balls, I'm pretty sure, are not going to work on a surface in the same way as a highly irregular mat. So I'm not sure how that's going to work. Possibly, Chris. Do you see what he's trying to say, little one?
A fluid spectrum.
Okay. If you had a
Yeah.
trough, nice laminar flow of water, just have a couple little. If you introduce
your stuff
pulp
there,
here,
shit would fall out.
some's going to settle faster.
Kind of like in a lutriation column, but on its side.
Yeah, basically. Yeah. Exactly. Might very well work in this situation, Chris, because it's a very consistent particle size. The sulfide particles are generally kind of subangular, but not needle shaped or anything. So they're going to settle in a similar way. The gold could be the fastest settling because, first of all, a lot of them are spheres, and of course the density. So by getting the fluid flow right, you had like two hoppers, and they had two hoppers here. By getting the speed correct, you should be able to adjust it so the gold's falling in this one, sulfides are falling in that one. Well, and the other thing is too is if you didn't have a highly classified feed, then it wouldn't work too well because larger, less dense particles are going to fall faster than a smaller, higher density particle. So, I say it's one of those things that it might work, Chris. It might be something that would come in handy in the future when we have a little more time for pure research. Yeah. Yeah, I would imagine, and the material would also, you couldn't have like some stuff that's some particles that are really flaky and some that are not, but that both of them vary in terms of densities. If all the flaky particles were the less dense ones, that would be just fine. You know. Yeah, what's known as settling velocity, is because the higher the settling velocity, the less it's going to be deflected. I mean, higher the settling velocity, faster it settles, the less it's going to be deflected to. This vector here, this horizontal vector, is going to be less effective on it. Something with a lower settling velocity, once it takes longer to settle, is not only going to drift slower, but it'll be more significantly affected by the sideways moment. So
it would be kind of interesting to try.
Yeah, I say we're just got enough stuff to do right now.
Yeah, I know.
And we may wind up not even worrying about it too much because in the long run we may just take all the gold and all the sulfide and everything, just roast the sulfides and then leach it all and electroplate it. Well, flotation is also such a useful tool, and there's so many more minerals that float well as opposed to gravity well, you know? That I think that gravity separation is just not as exciting as it used to be. It doesn't mean it doesn't work though. So, see, sulfide versus oxide. Yeah, plus I'll be doing my dissolution experiments this week, you know? Uh, and we'll see how the various lixiviants stack up. Eco Gold X versus glycine versus thiosulfate. And I got all the chemicals for everything. I just got the gold leaf today. So I'll get set up on those tests and see what parameters. I've got a meter for oxygen reduction potential and everything too. So I should be able to check a lot of parameters and go from there. Yep. Anything else? We're going to be sending off some samples to Hiddle from the across the road area, and that'll be interesting to see what happens there. Especially curious to see what he finds in that the across the road sulfides. Now, little one, when you looked at this, you saw what looked like gold particles stuck to some of these things, didn't you?
No.
No.
I saw a typical what happens with typical sulfides that have become oxides. Get that classic oxidation.
Well, that's what I said. On this rock here, I saw one that's a round sphere.
No, I did not see any ground.
Yeah. Anyhow, I believe I saw some gold on this. It could be chalcopyrite in some cases, but we will find out for sure. Unfortunately, I suspect that this real high quantities of silver colored heavies is a result of I'll do what I can here.
I think we found one extraordinarily hot.
I think there was one really good rock there.
Yeah. That's about all I can figure because nothing else.
Let's see if we can do this here. Part two. Reverse. But anyhow, there's a lot of silver colored stuff in there. It's not showing as such on the large. Yeah, I'm trying to figure out a good way to getting some photo micrographs. See, the nice thing is I've got these cards now, so I can go ahead and once I can get a good photo micrograph, I can show y'all. Come on. Wow. Okay, man.
Thanks a lot. That really hurt.
What do you call that? That thing, you know, flashing lights can cause some people to.
There. Did it again.
I put it behind my. I can't turn it off without moving it.
Well, then don't point. So that hurt.
I'm sorry. But I just want a flashlight that turns on and off. Yeah, I'm not. I need a good microscope that takes good pictures. Trying to get the light's kind of hard. But anyhow, so it's really not. It's not that easy to see without an actual microscope, but it is recorded. So I'll be roasting that tomorrow and seeing what I can get out of it. Trying to think if there's anything else really.
I don't think there. Well, I mean, not on the okay.
Yeah. I don't think so. I mean, we did a modest amount of stuff in the last day or so, but the next week it's going to be busier than heck. Expect a couple, 3 videos this week, folks. That's it. Get a ring light for displaying a card form like that. It'd be better to just have a photomicrograph on the computer that I can show you. Trust me. Unfortunately, that little microscope that does such a great job when you look through it doesn't do such a great job on a smartphone. Eva says she's got like a macro lens that works
Yeah, the
reasonably well.
macro lens that bought.
Yeah, except you don't have it here, so we got to go over there. What do you remember? What the magnification was?
No, I don't. It was like 40 power. It got
Okay.
different things.
Okay. So, anyhow, um, once we got some photomicrographs, then we'll go ahead and we can post them, and we can also call them up on the computer to show during the show and tell section. But that's what I've been up to this week. Anyone got any questions or subjects or anything they want to chat about? Not yet. I know exactly what you're talking about, Chris. No, I haven't checked it yet. But that's one thing. I know it's got a USB port because that's how I charged it. I plugged it into the USB.
Yeah, we're going to.
We'll worry about it this week. You know. So let's see. Did you take the mice out of the freezer?
I'll be.
Yeah, her snake needs to eat more, so trying to get it more calories down its gullet. Yeah, but then we'd have to figure out how to do that. Might be able to use it as a video source for the stream. Possibly. We definitely know how to bring up picture files. You know?
Yeah. Let's get something really, really crystal clear here. The goddess already does not like having to manage all the text. There will be no excess text.
Anyhow. Why do some people use salt when they roast black sands? It's to make chlorides. I believe that when you roast certain black sands, they're trying to turn the gold into gold chloride, which is pretty easy to dissolve. Talk to us about Montana B. As we got deeper in the decline, the original assays weren't representative of what the ore we were actually moving. So the profitability wasn't there. So the owner didn't want to just keep continuing, spending money if it wasn't going to become profitable. There is a possibility once we get below the 40-foot level that we could, get into some better grades. But we'll have to see. First of all, the generator that we were using out there basically gave up the ghost. I mean, it was already getting pretty darn worn and burning oil and stuff. And then while it was sitting on the trailer, bouncing around the roads, it broke the motor mounts and it's safe. So we're going to have to get a new generator before we can do anything more there anyhow, because we have to hoist the material up. I can definitely load a bunch of material down there at the 40-foot level, but the winch that we're using would start getting pretty hot pretty fast. It likes to have lots of time between trips to cool off. And so as we're going down, it's getting more expensive and harder, and the grade isn't staying where we wanted it to. And so we just, kind of put that on the back burner. Comes to top of the hill, the grade of the quartz is, marginal, third to half an ounce to the ton. But again, it's not going to make a pile of money. And so it was decided that the best investment at this time was to look for better grade somewhere. That's why we were out there on top of the ridge at Montana B, checking out other things.
David B said to go right or left.
We were going straight down the decline at Montana B.
Yeah, he's asking whether we checked the
we pretty much checked everything that you can get to there, and the only thing we found with decent grades that were amenable to exploitation were along that middle decline. At Pack Rat Penthouse, there's some good grades still sitting there, but it's holding up the roof, so to speak. So exploiting that, there's not enough there to make it worthwhile or the risk. And so we sampled along the perimeters of the stopes and bottoms of the decline. I mean, for example, the lower decline at Montana B, you got this much material, a half an ounce to the ton. That's not terribly profitable. And so again, it's not that there's nothing there. It's just there's not enough to make it decently profitable.
The perennial problem with all mines,
yeah,
is you don't have economy of scale.
Yeah, the cost is high enough, production is low enough that it just wasn't exciting enough for the claim owner to want to keep putting out the effort on that. When I get these solution tests run, there's a gentleman from Whitehall that was interested in any solutions that were not cyanide because of regulatory reasons in Montana. And so if the thiosulfate or the glycine leaches do well, once I get a little familiarity with them stuff, then I'll call him up. And he has some potential projects there. I talked with Jeff Block, and they were unable to get the well drilled on their property over here until I believe it was September. So they did not move over here this year. They're going to stay in Florida for another year, and then theoretically be rocking and rolling next summer. We'll see what happens there. I currently don't have a nice high-grade deposit. Got accessibility without permitting and stuff like that to exploit. But that's why we were spending so much time. You noticed a lot of our videos this year were basically exploration. That's why. Trying to find something that's pretty good. Oh, I wouldn't be surprised, Brian. A lot of this is just regulatory. Um, there's a, I'm not sure exactly where it is, but someone was saying, yeah, they got the biggest gold deposit in Montana is just sitting there because it needs to be open pit heap leached, and you can't permit a new cyanide heap leach. Not for an open pit, against the rules now, against the law, not the rules. Sorry, against the law. No way to make it compliant. It's just simply forbidden. So until they change the rules, it's just going to sit there. I have no idea what else is going to happen here, but I got plenty to keep me busy, and we're having a good time. But um, we're just not putting forth the kind of intense effort as we did last season, which I don't mind a heck of a lot. Getting older, so working my ass off is less and less enjoyable.
Oh, you could not mind a heck of a lot all you want.
Uh, so I say we shall see. It's one of those years where you're kind of adjusting and doing a little different things, and then wind up in a different routine. Kind of a transition year. That's my feeling. Um, but again, we're paying the bills, got a roof over our head, got interesting things to do. Why worry? It's not exactly where we'd like to be ideally, but what the heck? Well, these guys, Central America, that's a really fun and interesting project. A little frustrating at times, working at long range like that, especially when it's like, if I was just there, I could pan it myself, sort of thing. And one of the things when they get the samples here, I'm going to go ahead and try and pan out the gravity gold, see how much there's in there, and then I'll be sending it off for assay, roasting it, sending that off for assay, comparing the weights and the grades to make sure I didn't lose too much in the volatilization, and then I'm going to have a leaching testing on that ore. Again, theoretically, 3 different leach solutions, get the optimum parameters, then try it with the ore and see which one works the best. And then I theoretically am going to be working. I have a design on the computer already for a tube roaster that will roast sulfides on a continuous basis, and also give us the ability to extract the fume and either discharge them in a way that doesn't harm anybody or run them through a scrubber. But at least the fumes are going to be confined and amenable to dealing with it. And yeah, I think you're right, Brian, but that's what I'm going to be testing. And I also need to test, for example, if you have a bottle roll as your major method of dissolution of a very high grade concentrate, um, it would be advantageous if you can get sufficient kinetics at room temperature. I mean, if I can get 100% recovery in 3 hours at 130 degrees, but I can get 100% recovery in 12 hours at room temperature, hey, it's just rolling. Go do something else. Indirect, Chris. Basically a rotating kiln, tube kiln with about a 2-inch pipe and a kiln around the pipe, and that's my basic plan. It'll be easier to keep from blowing away gold and stuff like that. Where's your fuel coming from? In the case of the roasting furnace, the plan is propane. That's your most versatile, easy to control heat source, especially in a third world. Very portable. The tube kiln, the tube roaster for sulfides should be overall, I think it was 6 or 7 feet from one end to the other. The actual heated part of the tube is about 4 feet long. And an auger to feed it. I wasn't planning on paddles inside the pipe once the stuff is in there. I'm just, it's going to be fairly flat lying. So I believe just climbing the wall and getting dropped as it slumps will probably give me adequate agitation, so to speak. Be easy to tell. It would be nice if I can just take, like, 2-inch stainless steel tubing and just turn it. And, inside a 4-foot long oven, so to speak. It should work okay, says the dude that doesn't know everything. So I say that's something to deal with.
Oh, eating game.
And design the scaled up, what do you call? Yeah, augers are a lot more complicated than a pipe. It can be done, but if you don't need to do it, Brian, you save a lot of effort and complexity. How are you going to clean out an auger if it gets plugged up? A pipe is real easy. We shall just see how it works. And it'll be easy to just look in the end as it's turning, seeing what happens. I was figuring on using, like, let's say a 2-inch pipe with a 1-inch auger bit as the feed screw. Just a regular wood auger bit laying in the bottom of a V trough, turning. It's hooked to the pipe, so to speak. So it's just feeding the stuff in there, and then just a little bit of tilt on it. By adjusting the tilt properly, you should be able to get just the right feed rate so that it feeds all the way through and comes out the other end when it's ready. So we'll have to see. But the plans look good. Let's see what happens. And once I do that, then I still got to get the dissolution stuff. That's after the roasting. So we got, do we use bottle rolls? Do we use, like, a cement mixer? Depends on how much material we have to deal with. As a general rule, if I had my druthers, I'd rather go with, like, 20-pound bottle rolls than a 60-pound cement mixer charge. Stainless is terrible at conducting heat. Well, the design would easily switch to carbon steel. Might be the positive with stainless is not going to get corroded too fast, but if you're just using steel tubing, and I mean, I'm not going to have bearings. I'm planning on just have like a clamshell for the oven and holes at each end, and you just lay KO wool top and bottom. Just lay it in there. As it turns, that's your bearing, the seal and a bearing at once. And so, I say carbon steel might, if it lasts a reasonable time and it's easy to change it out, then not a problem. I mean, if you had something, for example, where you just have your feed mechanism clamps onto the end of a piece of plain steel pipe, okay, then, and all you need is a piece of 5-inch long, 2-inch, I'm sorry, 5-foot long, 2-inch steel pipe for tubing. Yeah. How hard is that? Oh, I'm not expecting it to last a long time. I'm not talking a thick layer either. I'm talking so it crushes down to like, 1-inch cable crushes down to like 1/8 of an inch thick. And, you run it for a few hours one day, and then the next day you can add if you need to. You could go with carbon lubrication if you needed to. Okay, Adventure Time. Thank you.
What?
It will powder the KOL? Yeah, maybe. I wouldn't be surprised. I'll figure it out. If I have to, I can make a tighter fit, or I can, I could have bearings, but then that's another wear point. On the other hand, if your main tubing is essentially a sacrificial thing, not a huge problem. Yeah, I mean, that's first iteration never goes perfectly.
Well, the goal is to make it as low tech as possible.
Yeah.
If parts are made out of, random shit that you have to replace off, oh well.
I mean, Chris brings up potentially a very important point, is the thermal conductivity of stainless, he says, is pretty low. And, well, as I say, again, the problem with a grain auger is now you have the auger inside the tube, and the auger is going to get corroded pretty fast too. So now you have a complex what do you call it? Complex wear part, an expensive one, as opposed to a cheap, 5-foot chunk of steel tubing. That's a cheap wear part.
Yeah.
A 5-foot long auger, 2-inch in diameter. Yeah, that's not a cheap wear part. So let's say by just tipping the tube at the right amount of tip, you should get the charge advancing at the rate you need. By changing the rotation speed and the angle and the diameter of the auger itself instead of the feed auger, you should be able to get these things balanced pretty well. Maybe right, Chris. I'll have to check it out. But yeah, I don't have a huge attachment to the idea of stainless. Just it would last longer. If it's not going to do the job as well, again, something that'll just clamp onto a piece of 2-inch steel pipe or 2.5-inch steel pipe, That's fine with me. How much cleaning maintenance do you put into that? Into that, you mean the theoretical roaster? I haven't put anything into it yet because it's not built yet. I would presume not very much. I was planning on the outside of the furnace being made out of sheet steel and then casting a refractory liner in it, um, so that you have a cylindrical, looking at the end, have the oven and the tube, then sheet steel. Basically have this split so that you got two halves with hinges. Just open it up, pull stuff out, drop new stuff in if you need to, go from that. But have it nice and cylindrical so that if you have one torch going this way and one torch going that way, you get a nice vortex of flame. Put it in at one end, comes out the other. You feed the cold stuff in at the other end, that starts preheating it and getting it hotter and hotter and hotter as it comes through. You know? What's a good grain size for lead oxide liberation? I presume what you mean, Adrian, is what is a good grind size so that you're going to get lead oxide away from rock when you do your separation? If that's the question, generally somewhere in the 100 mesh range, plus or minus, usually works out pretty well. Yeah, I don't think it's going to take the temperatures I need, honey bunny. I understand what you're saying, but yeah, I don't think it'll take 1200 degrees for very long. But the actual, I mean, the actual torch, that's pretty easy. You have a gas line, or with an orifice into a pipe. It's pretty low tech stuff, you know. B, are you trying to recover the lead as a product? Yeah, I said it's. Besides, how do you move the stuff through a water heater? There's a lot of issues there. But anyhow, oh, are you talking for the using the water heater for this thing here? Uh, Bigger than I need by quite a bit. That means it's all going to be a lot heavier. Okay. I've also checked out the size of metric stuff so that we could fabricate this. Say in Central America, you wouldn't ship it there, just fabricate it there. you know, you take a little bit of sheet metal, cut it, bend it, put a refractory lining in it, cast it in there. Pretty basic stuff, you know. It can be totally free the first time, but how do you do it 100 times exactly the same? Okay. I'm not designing one-time application. I'm designing a device that will be duplicated again and again and again and sold again and again and again. That's the idea. All these devices are designed to be produced and sold in addition to being used the first time. Okay?
And be able to be made out of local materials.
And make it relatively cheap with inexpensive fabrication techniques. Yeah. My thought was, Chris, what is the weight of a 5-foot long piece of 2.5-inch steel pipe? 10 pounds, maybe? So if you have your oven, put here, you can open it up. You have a hole in the end. Hole in the end. And a lip here to keep the pipe from falling out. Open it up, drop the pipe in, close it up. Pipe sticks out here. Drive mechanism here. Got auger feed here. And a bin there. That pipe turns. I was assuming that since these don't need to be very tight, you could probably just wrap some kale wool around there, push it down, and leave it at that. Yeah. That just makes it easy to service, Chris. That's all. It doesn't, it also means that it's very easy to cast the refractory here. You know? Casting this chamber here. Just take that trough. Oops. Take the trough, lay it down, stick a piece of pipe in it, pour in the refractory, smooth off the edges, let it harden, pull the pipe out, do the same to the other. These two are essentially identical. See? Yeah, 2 propane jets, Brian, is the idea. What might be the value? Decade-old Garrett metal detector with coin differentiating setting. I don't know. How about you, Chris? You got any idea on an old Garrett? I was figuring about a 2-inch annulus around the pipe itself, which was 2.5 inch. And the reason I did that, so that this part here, you'd have a 2-inch piece of pipe that extends into this other one. Then from here, just hook on an auger bit, lay it in the bottom of a trough here. So the auger bit feeds into this 2-inch pipe, then drops it well past the end of the 2.5-inch pipe. You know? Yeah, I don't know either about pricing. See, my thought was,
if you're wondering about pricing, I would look for a local prospector club in your area and ask them, because they would be your most interested market.
you know, but my idea was any size annulus bigger than what you need to get good fluid flow is just wasted. You're going to have a more area of refractory to heat up. Yeah. Adrian. So that was my first iteration plan. And thrust bearing here.
How universal are beer kegs?
Thrust
Well,
there.
it depends on how far you are from a city where people have beer kegs.
Okay.
I would think.
And so, again, the idea was just it lays in here. Can't go this way because of this thrust bearing. It can't go that way because of that thrust bearing. And you just have a chain sprocket here, gear motor. Chain between them. That was the basic concept there. Then if you put a couple jet here going that way and a jet here coming this way, again, these are basically the exact same shells. You have two of the exact same thing. Except flip it over, that one will come this way and this one goes that way. Angled back just a little bit, torch go like this, so this becomes the preheat zone for the sulfides. Get hotter and hotter and hotter as they're moving counter current. The heat profile. This will be the hot end, this is the cooler end. Then this area right here, between the hopper and this housing here, can easily be enclosed with a couple little pieces of sheet metal. And then there's your exhaust going out there. So that was the basic idea. Piece of pipe, sheet metal, scraps from this are used to make this hopper. The mount that holds the hopper, two pieces of sheet metal that connect here to there, and therefore forms the ducting for your exhaust. It all cuts out of one sheet of steel. So that was my idea. Whether or not these will work adequately as bearings, I don't know. You could always put bearing there, bearing here if needed. Let's say my thought was if it squishes down to a pretty small gap, the KO wall will probably last, I don't know, 12 hours of operation. So every week, day, whatever, just open it up, add a little bit of KO wool if you needed to. Again, you could probably use a graphite mat, or something to that effect. But I don't know. I'm just, thinking. But that way, that wouldn't have to be anything really complicated. And the only thing that would wear would be KO wool, which is pretty cheap and easy to replace. I don't know. That's a good question, Chris. Say if it doesn't, I'll probably have to put a bearing in there. But shouldn't be that hard. I haven't really tried friction against KO wool before, so I have no idea. But I'm sure they make the equivalent of high temperature packing. That's the phrase I'm like a packing cord. You could use a high temperature packing cord. Something like graphite fiber or something. Yeah, I understand, Chris. Uh, yeah, let's say it might be a carbon fiber packing cord or something. I don't know. I mean, you could theoretically make your refractory the bearing surface. You know, there you go. That's what I'm saying, Chris. I figure it's not going to be terribly difficult to figure that out. But say there's a little bit of heat leakage. It's not a problem. It doesn't have to seal tight. You know, could be. Say, I'm not exactly sure what the best thing to do is. If I stand it on end, the stuff falls through there in about a second, Brian. I need it to stay in there a retention time of probably at least 30 minutes. That's a possibility. Hmm. Hey, Red Wing, how's it going?
Hi, Red Wing.
He's saying take a graphite crucible and use that, put a hole in it. That works. It doesn't have to seal real, and it doesn't matter if it, as long as it runs freely, a little bit of gappage is going to be a problem, you know? Well, it has to have a lot of airflow through it also, Brian. Okay? It's not going to roast, oxidize anything if you don't have a lot of airflow, you know? So, I mean, rotary kilns are pretty standard stuff, cement, lime, things like that. They typically are, they're much bigger and they have the fire in the middle of the kiln going down it.
It's the same sort of idea.
Could be, Chris. Yeah. Yeah. Put them on the outside. They could also be thrust bearings at the same time, you know. No, Jeff, there's no auger inside it. It's just a tube that's rotating. And with a little bit of tilt to it, as it rotates very slowly, 1 RPM or something, then the material is going to tend to go downhill. It's a matter of how steep do you tip it, how fast do you turn it, what's the retention time you need to get through a roasting by the time it falls out. All that can be adjusted after it's built to figure out the what works good. This little auger, this part is the auger. Screws in here, feed material into the device. Then it's just plain tube is the plan. Sulfur is going to ignite. Works fine for me, Brian. Don't have a problem with that. That just adds more heat in the middle of the tube. You know, I say you got to turn the sulfur into sulfur dioxide. That's the whole idea. Yeah, I say that's just it. It's just laying in a trough. You have a feed bin like this. The auger's in the bottom. That's it. Well, is it going to be profitable, Red Wing? Yeah, they're not terribly pricey, Honey Bunny. They're about $10 to $20 depending. You know, may take the gold. That's what I have to test, Brian. Yep. Maybe, Chris. Don't know. Yeah, and that adds complexity, time, and cost, Honey Bunny. If it'll feed, guarantee you, those big cement mills don't have augers in them. Material just feeds by gravity. Absolutely. If you have a nice granular material that doesn't get too sticky, that'll work. Neither one's terribly efficient, Adrian. uh, well, that sucks, Red Wing, but you do what you got to do, right? Yep. Another moving part, Honey Bunny. Yeah, exactly, David. Anyhow, what time is it? I think it's 7:30, 7:50. Yeah, it's about time. Anyhow, it's a rough plan at the current time. Worry about the details when we get to that. Among other things, I need to know what temperatures and what time retention times. But by using a variable speed motor here, by being able to just change the tilt, you got a lot of adjustment there without too much trouble. No, I can't, but I can turn it into one moving part with a chain drive that has another moving part. That's the motor. That's it. Two moving parts. End of story. You got hired at a mine. Well, good for you, Sarah. What are you going to be doing? Equipment operation or milling or what? Agreed, Honey Bunny, but also by putting an exhaust pipe on this and having reasonable uh, seal around here and everything, and just the heat will, what do they call that? The draw? Yeah, chimney draw. Exactly.
Yeah, same kind of.
Yeah. Blonde heavies, could they be? Scheelite, barite. I'm not sure what else. Chris, any other blonde heavies that come to mind? Uh, if it's scheelite, it can be fairly valuable, and you can tell by using an ultraviolet light. Scheelite will glow. Draft. There you go, Chris. Exactly. Just put a pipe there, and it'll get a pretty good draft going. Oh, I agree, Honey Bunny. But it adds a lot of fabrication complexity. And how do you clean out the tube if it gets plugged up? Again, now you got to pull the auger out and this and that and the other. It seems likely that it will not need it. again, Sarah, what exactly is the job that you've been hired for? You know?
Yeah, we want to know.
Yeah.
Wiring minds and all that.
So, I say, as far as I know, an auger is completely unnecessary. Get the tilt right, and have adjustable tilt. You don't need to worry about it. You know, we'll see if the stuff gets sticky. It's going to be even worse. What you have to do then? We'll play it by ear. Again, this is what the testing is all about. Yeah, really dense. Both scheelite and barite are really dense. Absolutely.
Yeah, got our own
Scheelite is tungsten.
We have our own blonde heavies running around right.
Okay. Yeah, when it comes to the feed auger, say you can buy a simple wood auger bit pretty darn cheap, and they're all the same. Makes it easy enough to deal with. Uh, I've never seen a real sparkly white heavy, Chris. What would that be? Thank you, Mr. Virtue. Yeah, that was the idea, Honey Bunny, exactly. It's just hooked to the roasting tube. When you're roasting, I did note a layer of crud on the iron plate that constantly needed scraping. Okay, we shall see. The auger itself would be basically full. I mean, it's brewing, pulling stuff in. Once it gets to the pipe, it just dumps it in there. Are tellurites white or are they silver, Chris? My mental concept of white, which silver technically is white, but to me, I would not call that white. I would call lime white, but not silver. I would call that a shiny silver mineral. As we'll see, honey bunny. Again, being a production machine, I want to be able to go down to Venezuela or Nicaragua or the Congo and buy the stuff that I need to make the thing there. You know, that's the basic concept. Sylvanite. Okay. If it's really heavy, it's interesting. It's easy to find out. Take it to a lab and have them run a multi-element analysis on it. But it's definitely interesting. If it's heavy, it's interesting. Oh, anyhow, uh, I am getting a little bit tired here, and I got stuff I was planning on doing. Any other questions or anything at this point? we're pretty much talked this out to the depth to this level at this point. I will definitely take your thoughts into consideration, Chris. Slightly brassy white. Any other subjects or anything? You can
Can stone dust explode?
depending on the dust. Let me think. Coal dust certainly can, but you wouldn't think of it as a stone. Sulfur can explode. That you don't normally think of as a stone, though, but it is. Are you trying to build an autoclave? No, it's not. No pressure at all. Airflow through it, just to heat the tube.
Roasting.
Yep.
An easier set and forget system for roasting sulfur.
Yeah. Now, another possibility is pretty cool. If you were to take this part here and make it vertical, get this tube hot enough, I noticed.
You're very welcome, Adrian, and pop in anytime. We're here every Monday.
You bet. If you trickle the sulfides down a glowing tube that's hot enough, they instantly flash into oxidization. I say, so theoretically, you could have this hopper feed a trickle down the tube, basically vertical, and it should still work if it was hot enough. You know? Most ore is pretty well oxidized already, Jeff. So you have to have something that can be oxidized. You could have, I'm pretty sure that powdered sulfides, like powdered pyrite, might explode. Yep. So there are a few, but not the usual stuff. Okay. Well, I think we're pretty well done. I'm getting kind of tired, so I think we're going to call it a night here. Go ahead and get ready there, honey bunny. Powdered metal. Okay. Yeah, if it's an unoxidized metal, normally you wouldn't be getting that from a mineral. But yeah, if it was actually a native metal, it might. So go ahead and post, honey. As I say, you can say I got plenty of interesting stuff to do. This is, kind of this is part of the stage 2 process, roasting. But I need to know, can we roast it safely, or are we going to lose a lot of gold? So until next week, folks, and thanks for showing up. I appreciate all the help and input. So happy prospecting and keep it safe out there.
Good night, everybody.